Welcome to another session of Engineering Economics, INEN 2373. In this occasion, we're going to talk about the analysis of the suppliers and how attractive it is for suppliers to offer the product at a particular price. So in order to do this, I'm going to explain the major concepts of marginal cost and average costs and how that relates to the setting up of the prices in the market. I'm going to have two examples. The first one is the simplest, and then we're going to go deeper into the analysis of this. So consider this table in which we have the possibility to work at the manufacturing plant at different levels, and these different levels of activity can be measured by the number of workers that we have actively working in the manufacturing side. So if in this example, if we have one worker only, the output will be 50 units, and if we have two workers, the output will be 140 units. If we have three workers, we will have 220 units, and so on and so forth. So the more workers we have, the more we produce. As we've seen previously in the course, we could have a fixed cost, and this fixed cost would remain the same regardless of the level of activity, regardless of the level of output that we have. So in this simple example, we have $100 regardless of the number of workers. Now, assuming that each one of the workers that's the level of activity that we have, cost us $80 for each one of these workers per month or per week. The variable costs that we will have, just the variable costs, are making reference to the level of activity, and we will have $80 for the first worker and $160 for if you have a level of activity that justifies two workers, and $240 for three workers. That is, in this example, each one of the workers costs to us $80, and so on, all the way up to $640 for 8 workers. And if we add the fixed cost and the variable cost, we obtain the total cost. So the summation of these two previous columns yield the total cost, and I have a short name of TC for total cost. And we start with 100 plus 80 is 180, 100 and 160 is 260, and so on. Then the next one is the average fixed cost, and that is just how many dollars it costs per unit, just the contribution to the cost of the product given the fixed cost. And naturally, since it's fixed, the more output we have, the less contribution or the less average fixed cost we have in each one of these items. That is how we spread the $100 among the number of total units we produce. So 100 over 50 in output, that's $2 per piece. But if we can produce 140, then the average fixed cost is reduced to $71 cents. And if we keep increasing in output at 220 units of output, the $100 are spread out to 45 cents a piece, and so on and so forth. If we continue to do that, we have the average variable cost. The average variable cost is 160 when we have an output of 50 units, because we are spreading out $80 over 50 units. But when we have the average variable cost is $101.14 if we have two workers, because we have to now spread $160 of variable cost among 140 units of output. So for a while the average variable cost reduces, but then after a while it starts increasing, and we have to ask why. Well, the reason for that to happen is because if you notice, the level of activity from going from 0 to 1 allowed us to produce 50 units. extra. That is from 0 to 50, we have 50 units extra. But from going to a level of activity from 1 worker to 2 workers, that increased 90 units. So it's a very significant improvement. And then from that moment on, we have decreasing increment of output, or diminishing returns, we call it in the economy. So how this works, if we go to a level of activity of 3 workers, the benefit is now in the output 80 units. If we go from 3 to 4, the benefit is now 70 units. And if we go from 4 to 5, the benefit is now 60 units. And the next time from 5 to 6 is 50 units, and so on. So each additional worker that we have does not contribute in the same way to the contribution to the output of the system, regardless of how many they were. It depends on how many there are before. And the logic of that is very simple. Think about any manufacturing facility as it goes fulfilling its capacity, then the servers become more saturated, and there is work in process in the shop floor, and orders have to wait for previous orders in the machines to be finished before they can be processed, and so on. So the higher the level of activity, there is more blockage and less productivity. And the same thing happens even in a retail store. Say for instance, if you're selling ice cream, you have one people only selling. Maybe that's not going to be the most efficient, because he or she has to sell the ice cream and also, that's to serve the ice cream and also collect the money. Maybe you have 2 people that will increase the sales, because now you have someone who can specialize in collecting the money and other to serve the ice cream. And you can keep increasing more people, and that's going to probably help you for a while. But if you keep increasing more and more, then they're going to block each other, because they will want both to reach the same area, or it's just going to be confusing. So the question is, how many more workers should we have? And that's why when we compute the average variable cost, taking into consideration the cost for having these many workers, we don't see a straight line. We see a diminishing return, and at the beginning we decrease the variable cost, but then later on it starts to increase. And that the overall effect, if you compute the average variable cost and the average fixed cost, you add them together, you have the average total cost. The average total cost, again, is going to diminish for a while, but then it might start to increase. And there is a very important concept, which is the marginal cost. And the marginal cost can be thought as the derivative of the total cost. And as an approximation for the derivative of the total cost, what we would have is the difference in the cost divided by the difference in output. So the difference in cost for the first $180 is $180 divided by $100 minus 0, because we started at 0 cost, divided by 50 minus 0, because we started at 0 units produced. And if that's the case, then we divide $180 by 50, and the marginal cost is $360. Now, in order to compute the marginal cost for a level of activity of 2, we need to take into consideration that now we are adding $80. That is from 80 to 160. We added $80, and the number of units we produce increased by 90 units, from 50 to 140. And therefore, if we divide $80 by 90, that yields 89 cents. If we can go on for the next value, we can produce, but the total cost is increases from 260 to 340, and that's $80. And we also increase productivity, or the output, by 80 units. So the marginal cost is now $1.